Today, we're going to pull back the curtain on one of the most important parts of your computer, its memory. It's really the secret to how your machine juggles everything you ask it to do, and it all boils down to a really clever compromise. Have you ever been there? You're in the middle of something important, and your computer just starts to crawl, even though you know it's got a super fast processor inside. It's frustrating, right? Well, the problem usually isn't the computer's brain, it's the workspace it has to use. Okay, so to really get why that workspace is so critical, let's think about the computer in a really simple, almost human way. It's all about a brain and the space it has to do its work. This really breaks it down perfectly. You've got the central processing unit, the CPU. That's the brain. It does all the thinking, all the calculating, all the heavy lifting. But it can't do any of that in a vacuum. It needs information to work with, and that information is stored in the memory unit. That's its workspace. And that leads us to a really simple but powerful truth. You could have the fastest brain on the planet, but if it has to get up and walk down a super long hallway every single time it needs a piece of paper, well, the whole process is going to be incredibly slow. At the end of the day, your computer speed really depends on how fast that brain can get to its workspace. So this is where things get interesting, because it turns out there isn't just one kind of memory. There are two main types, and they force a fundamental trade-off, a choice between speed, size, and of course, cost. First up, we've got primary memory. Now, the best way to picture this is like a small, perfectly clean workbench sitting right next to you. Anything you put on it, you can grab instantly. It is incredibly fast. But because it's such prime real estate, it's also kind of small, and it's expensive. And then, on the complete other end of the spectrum, you have secondary memory. This is like a giant library, or maybe a warehouse packed with filing cabinets. It can store a mind-boggling amount of information for a very low cost. The catch? If the CPU needs something from here, it has to put in a request and then wait for it to be fetched. It's much, much slower. So here's that trade-off in a nutshell. Primary memory gives you blistering speed, but you get less space and it costs more. Secondary memory is the exact opposite. You get a massive amount of storage for super cheap, but you have to sacrifice all that speed. You can see the dilemma, right? You can't just pick one. You really need the benefits of both. And there's one more absolutely crucial difference we need to talk about: volatility. Primary memory is volatile. Think of it like a thought in your head. The second the power goes off, poof, the information is just gone. Secondary memory, on the other hand, is non-volatile. It's like a note you've written down on a piece of paper. Even if the lights go out, that information is still there when you come back. Okay, let's make this real for a second. Just take a moment and think about the apps you have open on your computer right now. Your web browser, your music, that document you're working on. All of it is loaded up and sitting on that fast, temporary workbench. It's all living in your computer's primary memory, which you probably just know as RAM. So if you can't have one single type of memory that's both massive and lightning fast, what do? What's the solution? Well, computer engineers came up with a truly elegant one. Don't choose. Instead, you build a team. And that solution is called the memory hierarchy. Instead of trying to rely on one type of memory, computers use several different layers, all organized like a pyramid. This whole structure is designed to give the CPU the best of both worlds, to give it the feeling of a gigantic, super fast memory, but without the impossible price tag. So here's how that team is structured. Right at the very top, you have CPU registers. This is the absolute fastest, but also the tiniest memory, and it's located right inside the brain itself. Just below that is cache memory, which is a small, high-speed buffer that smartly guesses what the CPU is going to need next and keeps it ready. Then you've got our main workbench, the main memory, or RAM. And way down at the bottom is secondary storage, that massive library, like your hard drive, where everything is kept for the long haul. So let's take a quick look at how this team of specialists actually works together to make your computer feel quick and responsive. You're actually already super familiar with the players at the bottom of this hierarchy. We're talking about things like hard disk drives, CD-ROMs and DVDs, and of course, pen drives. This is that permanent, non-volatile library where all your files, your apps, and your operating system live. A simple USB pen drive is a perfect, everyday example of this. It's non-volatile, right? Your files don't just vanish when you unplug it. It's a reliable, portable little piece of that huge secondary storage library. The source material for this explainer puts it perfectly.
The overall goal of memory hierarchy is to obtain the highest possible access speed while minimizing the total cost of the memory system. You see, it's as much an economic solution as it is a technical one. It's about getting the most bang for your buck.
And the result of this beautifully coordinated system, it creates this incredible illusion. It makes the computer feel as if it has one single, gigantic memory that is also incredibly fast. By cleverly shuffling data between the layers, the system makes sure that whatever the CPU needs next is almost always waiting for it in the fastest possible spot. So, the single most important thing to take away from all this is that your computer's memory isn't just one thing, it's a team. A carefully balanced team of specialists, where each member plays a vital role in managing that constant trade-off between speed, size, and cost. So I'll just leave you with this final thought. The next time your computer starts feeling sluggish, when you have way too many tabs open, think about this hierarchy. Which specialist on the team do you think is struggling to keep up? Is it a cluttered workbench, or is the brain just having to make too many long trips to the library?